Okay, so take a few minutes to answer these 3 questions based off the figures above. Press pause. If you have any, answer the questions, which chances are they're asking you to write down some questions. So write down some of the questions that you may have that you would ask yourself in these particular situations. Pause and come back. Alright, so the first thing says, what questions would you ask to determine whether each figure, all 3 of them, are parallelograms? Well, one of them could be, are opposite sides congruent? Are the opposite angles congruent? Okay, those are some of the properties that we talked about. On the second one, it says, what questions would you determine if figure 1 is a rectangle? What additional questions would you have to determine if figure 2 was a square? Well, in figure 1, are all of them right? Are all the angles right angles? They have to be in order for them to be a rectangle. Also, for it to be a square, it has to be, are they all right angles? And are all sides congruent? In order for it to be the square, those properties must fit in order for that to be a square for the second figure. Now, for the third figure, it says, if all 3 figures are parallelograms, what's the most descriptive name for number 3? How do you know? Well, all the angles are not right angles in figure 3. But it appears that the sides are. So it is a rhombus. Now, most of the time we have to find this proof and we have to know all this. Okay, I mean, we have to know that they have the proofs, whether all sides are the same, whether it creates a perpendicular with their diagonals and all the things. Yes, I know this, but it's asking you basically in this problem, what's the most descriptive name for it? Okay, so it's basically asking you, make it that a little bit more where you can see. It's asking you in this, well, what's the closest thing you would describe it as? Okay, so that's what's asking you there. All right, got a couple theorems to go over. One thing I wanted to show that all 4 sides of a rhombus are congruent. Okay, so squares can be rhombuses. Actually, squares are rhombuses, but not all rhombuses are squares. A little confusing, but think about it for a second. Okay, if a parallelogram is a rhombus, then its diagonals are perpendicular bisectors of each other. Okay, so what that means basically is you create right angles and you're also creating equal lengths on their bisectors. Okay? Now, on the next one it says if a parallelogram is a rhombus, each diagonal bisects a pair of opposite angles. So basically what it's saying is, whoa, this angle 3 and 4 are going to be the same. 1 and 2 are going to be the same, but angle 1 and angle 2 are also going to be the same as 3 and 4. Okay? All going to be the same. So, all going to be the same when it comes to a rhombus. Okay? Alright, so, on to the next one. It says parallelogram is a rhombus. What are the measures of 1, 2, 3, and 4? So, in this situation, if it's a rhombus, these are perpendicular bisectors here. Because they're perpendicular bisectors, perpendicular means perpendicular creates 90-degree angles. So, if one of them is 90, they are all 90. And so, angle 1, angle 2, angle 3, and angle 4 all are 90-degree angles because they are perpendicular. Alright, so hopefully I'm going to try to fit this all in one video. If I don't, sorry, I'm going to try to. I don't know if you hear in the background, baby is up awake, And I'm going to try to hurry up and get this finished before it is bedtime for her. So the next one says parallelogram is a rhombus. How do 1, 2, 3, and 4 relate? Okay, well, if you notice this, those are telling us that those are equal, which basically now we create a isosceles triangle. Because we have an isosceles triangle and these two sides are equal, that means their base angles are going to be equal. It's not asking you what the angles are, it's just saying how are they related. So because JLM is isosceles, this is me spelling isosceles, then angle 2 and angle 4 are congruent based off that. Well, also too, when you look on the other side, you have JKL, also isosceles, because of their equal sides as well. So their base angles also have to be equal. So that means angle 1 and angle 3 are congruent, are also the same. Okay, you guys try 6, 7. You try 6 and 7. Pause, do it, and then come back. Okay, number 6. We are looking at a WY, which is this whole thing. Well, the reason why WY is 6 is because of this Z middle, which is 3. If that's 3, this is 3. But at the same time, the diagonals are equal to each other based off of what we just talked about here. Diagonals bisect a pair of not that one, sorry. Perpendicular bisectors of each other. So WY, so XZ is going to be 6, therefore WY is also going to be 6. So now if we go to now the next one, number 7, we have, just saying. Okay, sorry, a little bit of a backtrack here. I can't edit this out because I have the free version and the free version doesn't let me edit. So go back to number 6. The issue we have with number 6 is I made a mistake. As you can tell, this here is 3. And this, remember, because it creates perpendiculars, these are right angles. Okay, so we're going to focus on this particular triangle down in the bottom right hand corner. Because it creates a perpendicular, the right angle, this is the hypotenuse, ZY is the hypotenuse. And that is going to be 5. So in order to find this portion, we need to use Pythagorean's theorem. Okay, remember that is a squared plus b squared equals c squared. Okay, we have a and we have c. We don't have b. So that is how we're going to figure out what that piece is going to be. So we have 3 squared plus b squared is equal to 5 squared. 9 plus b squared is equal to 25. Subtract, we end up b equals squared equals 16. The opposite to get rid of a square is a square root. So what we do to one side, square root, sorry. Then we do that to both sides, so b equals 4. So this part right here equals 4, but we're asking for the whole thing. So if that's 4, this is 4. Therefore, the whole thing is 8. Sorry about that. I make mistakes too every once in a while. More than everyone once in a while. Okay, this one for sure is real. Okay, I've marked already what RPS is. So what I do is I'll go to the left triangle first, or the right triangle first, sorry. And I know that that is an isosceles triangle. Well, that right here is 70, so I know that these bottom base angles have to be the same. Okay, so what I did was I did 180 minus 70, got 110, divided that by 2 and got 55. Okay, well, next thing you know, those two triangles, the blue one and the one I'm going to mark in orange, they are the same triangle, basically. They both have congruent sides, or congruent leg here, and a congruent leg here. Then they also have a third leg that is congruent because they both are PR. Because they are both the same one, then we have the reflexive property, which is SSS. So if they're the same triangle, that means they have the same parts. So if this is 70 and the bottom two are 55, then it has to be the same thing with both of them, with both triangles. So then this becomes 55 as well. So that's where we get the 55. Okay, I need to talk kind of fast because I got about 4 minutes, and I need also to do about 3 more pages. So if this is a rhombus. Okay, so what it's asking for is ADE. So it's looking for this one that I just marked. Okay, so we know that this portion here is 53. That makes this 53 as well, because those two triangles are basically the same. They create the diagonals create angle bisectors. Okay, so now we start to take a look, and we have this isosceles triangle. Okay, so that makes this side 53 as well. So now I just take 180 minus 53 minus 53, and I get 74. So 74 represents all of this. But then you'll notice there's a line that bisects it. Okay, remember those diagonals are angle bisectors as well. So then I take the 74 and divide that by 2. And when I get 74 divided by 2, I end up with 37. So angle ADE, the green portion here, is 37 degrees. All right, now for number 9, it's asking for what is GH, which is this portion here. Well, we need to find x. When we find x, then we can find what HJ is, and whatever HJ is going to be the same as GH because rhombus, all sides are equal. So how can I find what x is? Well, I'll take this portion here in the diagonal and this other portion of JG and set them equal to each other. When I set them equal to each other, then I set them equal to x. I took the liberties to kind of do this for you. I set them equal to each other right here. So then I worked everything out, and I got x to equal 5. Once I got x to equal 5, I took that, plugged it in right there, and you'll see that I did it here. So 3 times 5 is 15 plus 1 is 16. Well, if this is 16, that makes the GH 16 as well. Do 10 and 11, pause, do 10 and 11, and then come back and I'll have the answers written out for you. I might not explain them, but I will have them written out for you. Okay, so what I have now is the answers for number 10 and 11. Notice the explanations, or notice the written on how I did number 10, and then also too look how I did number 11 as well. If you have to, pause on both of these so you can take a look at what happened. Alright, so the theorem says that if the parallel is a rectangle, then the diagonals must be congruent. So if you look at the triad, you have the diagonal measures of 52 and 53. Well, is the gate rectangular? No, because the diagonals are not congruent. One's 52, one's 53. Take a look at this problem here as I did all of them. Worked out, explain, use different colors, and the final answer is down here. Take a look at how I did that. Try the rest of this page, pause, and then come back with answers. Okay, take a look at these answers. Pause them because I'm running out of time. If you have any questions about how I got to these, just ask when I get back. My time is up.